Guys, let me remind me later. It's fine. Okay. Now, what I'm doing here in this problem statement, okay, here we are planning to create a practical session on dynamic SQL query generator. Okay, by using the AI. What you can do here? So basically, user will ask some query, the AI will understand it, and it will give you the SQL query. That is our goal. For that purpose, if AI does not have information about your database engine, or it does not have information about your object details, database object details, it might give you the wrong answer. For that reason, we need the proper prompt or instructions to guide the AI. Hence, AI will give you the proper SQL query. That prompt is called, that steps is called prompt engineering. You are giving the guide or instructions to the AI. So, in this project, what we will cover? We will cover 11 prompt steps. Okay. First of all, AI should have information about your database connectivity. Next step is we should provide the schemas. Okay. Can you analyze the schemas? Then build the knowledge base. That way, it will grab the entire information about your database objects, database tables, or you can say columns and the table relations. As per the knowledge base, it will start creating the SQL query, right? These are the steps. Turn natural language into safe, optimized Postgres SQL select queries. First, it will do a connectivity, analyze, generate, heal, and learn. Each step will show practically, right? And here, how many steps we have to follow? We have to follow 11 steps. If you are 11 steps means we have to put the 11 instructions, we have to give 11 instructions to AI so that your AI can make a complete product, safe product to generate the SQL queries. Now this is called my, here you can see, right, this is my Codex. It is already connected with Codex. This is about my prompt. This is about my prompt. So I have already documented step 1 to, if you scroll down, how many steps I have, how many instructions, 11 instructions I have written. By reading these 11 instructions, the AI can generate a dynamic safe SQL query generator. Now before going to start the practical, now let me show you, this is my database details. If you see here, now let me create the, click on the servers. I have Postgres SQL that is locally installed. And if you see how many schemas I have six schemas are available. I will focus only these 4 schemas. One is called account fulfillment, identity verification, onboarding score, and the risk compliance. If you will expand this schema, you can see the inside the schema you have schema objects are present. Schema object means you can tell your tables, your primary key, functions, everything is present inside the schemas. That means this is your schema details, right? Before, okay, this is my schema details. Let me show you the complexity of this schema table relations. So there is a ER diagram already I created. Let me open this ER diagram. I don't know whether you can guys see. This is the 4 schemas, right? Onboarding course or onboarding underscore core, identity verification, risk, and account fulfillment. If you see, just look here, it's a very difficult, right? The relationship is very complex. Just imagine if a human will understand this entire concept and it will start writing the SQL query by its own. It is a very complicated task, right? That is the reason we are using here dynamic or auto generation of SQL queries. Now let me close this file. So how many steps are here? 11 steps are here, right? So what I will do, I will execute the step by step. First step is what? Database connectivity prompt. Now let me let us execute step 1 from the prompt file. So what it will do? It will ask me. It will ask me, can you give me the database details? Accordingly, I will create a connect underscore postgres.py file. So why it is connecting? Why it is creating this file? Because already in my prompt I already told just create a. Let me go to down here. I have somewhere mentioned. Okay, the script should be Python. The script name should be connect underscore postgres.py. Now look here. So connection is successful because this is the host, localhost, because I'm using localhost. This is the port number and the database is Postgres. Username is also Postgres. Okay, that's why it is able to connect with my database. Which database? The database is running here in the locally. This is my database. Now, what is the next step? Okay, now tell me, once my database connectivity is done, what information the AI is required so that it can get the database details properly, or knowledge, what is called database object details properly, so that in later it can create a SQL queries for you properly, right? Now let me go to the database again, and this is my schemas, right? I have to provide the schema names, hence it can get the all the database details. Then I'm telling yes, continue the step 2. Step 2. What is step 2? This is called my step 2. Schema selection prompt. Okay? Because this information should required for the AI to create the proper database queries. It is listing all the schemas, right? It is listing the all the schemas. Now, what I will do, I have to give the schema names. I need these 4 schemas to be analyzed. I don't need all the schemas. I need this account, fulfillment, verification, onboarding core, and risk compliance. Let me, I have already written some text file. Let me copy this and paste here. I need these 4 schemas to be analyzed. Look here, it is selecting the schemas now explicitly set to these 4 schemas to be analyzed properly. Okay, next one is step 3. What is the step 3? Once you provide the schema names, it should analyze the schema. Analyze means it will get the information about the schema, its objects. Then I will tell, please continue. Continue for the step 3. Why it is going to automatically step 3? Look here. This is the step 3 schema analysis prompt. Use this after database connectivity and schema selection are confirmed. I am clearly mentioning you are a Postgres SQL schema analysis assistant. Your job is to inspect only the confirmed selected schemas that I have given here, right? And extract accurate metadata for SQL generation, relation discovery, and knowledge creation. That's why it is now it will start analyzing the given schemas. It will take some time to generate the schemas because look, right here automatically, if you see the left side, right, automatically it will create a Python script. This Python script, what it will do, whatever the schemas I have given, right, these schemas will be start analyzing. Now here you can say schema analysis.json. This is the my JSON file is created. Okay, this is the information about your schemas. Who given? Because of the step 3 or prompt 3, this JSON file is created by this Python script. And it is asking, can I step 4? What is the step 4? By using this JSON, it will start creating a knowledge base. No, knowledge base for whom? Knowledge base for AI. When user will ask, can you give me a SQL query or something, some report or something, it will follow that knowledge base, and it will dynamically generate a SQL query. Then I'm asking, okay, continue for the knowledge base creation. Continue for the knowledge base creation. So what it will do? Okay, now look, now let me go to the prompt file. And what is the step 4? Step 4 is SQL knowledge base creation prompt. Use this immediately after schema analysis is completed. My third step is schema analysis. What is the fourth step? Fourth step is called your schema knowledge base creation prompt. Okay, so what it will do? It will create a knowledge base, and the knowledge base file should be SQL knowledge base.md. That means automatically you can see here after some time there is a file will be created. The file name should be SQL-knowledge base.md. Why this knowledge base is required? This knowledge base is a complete information about your database. As per the knowledge base, it will create your SQL query. Now look, this is called my knowledge base is created. Total tables is 40. There is no views. Columns 282. Primary key is 40 and foreign key is 46. Index found is 49. 49 index are there. How many schemas? These many 4 schemas are there. This is the table details. This is called your table details. This is the foreign key details, and this is about your indexes. Why indexes are used? Why? Yeah, this is used for the query performance, right? Now this is the indexes. Now knowledge base is created. Now next step is step 5, right? Read only query generation boundary. Read only query generation boundary means I am telling clearly to the AI, don't do any write operations. This product is only dedicated to generate the read only SQL queries, not write purpose, right? Then it should keep somewhere in the knowledge base, right? When you are telling, hey, can you make an insert command, update command or delete command, it will tell no, I can't do, because my boundary is only read only queries. Then I'm telling, okay, continue. This is the 5th step. I will enforce read only boundary for the workflow. Create a small Python validator. Okay. Step 5 is validator out. So what it is doing? It will create a validator Python script. When user will ask the query, the validator will cross verify whether really are you asking. Okay. Now it is also modifying the readme.md file. The guard is created. This is the guard is created. Blocked keywords. If you are typing something here, can I do some write operations, insert, update, delete? The guard will block you. No, you can't do. It is only this product is designed to give you the read only access. Okay, next one is called my 6th step, right? When the SQL query will give you the query, that query should be optimized. That should not be very unoptimized query. If you are not writing optimized query or SQL AI is not returning the SQL query, the problem is the database load will be more and the query performance time will be, query running time will be increased. Now let me tell you, yes, continue. Continue the step 6. So what it will do? It will add some constraint in the knowledgebase.md file. Helper that reads, build step 6 generation prompt and validate any generated SQL through the read only guard. Look here. So this is about your step 6. Optimize query generator.py. Okay. So this Python script will help to generate select SQL queries, refuse query write, optimize rules, use only documented schemas, tables, use schema qualified table names. Validation before final. Confirm every reference. Use order by for deterministic last stop and all. This is about your optimized instruction. Okay. The next step is, so this is called your so latest 10 applications name application status example, right? Now let me copy and paste here. It is telling I will generate a optimized read-only SQL query from the knowledge base. Now look, onboarding and all, it is reading the knowledge base. Where is the knowledge base? This is called your knowledge base, right? It will cross verify the knowledge base, it will get the information, then it will create a optimized SQL query. Is this clear? Okay. Now the next step is continue the step 7. What is the step 7? Let me go to the prompt. Where is my prompt? Yeah, this is called my prompt, right? What is the step 7? Step 6 is optimized. What is the step 7? Schema drift self healing prompt. That means, look, today I analyze the schema. After some days or in near future, if my table name changed or column name changed, then it will create a, it will give you the what? It will give you some wrong SQL queries, right? To avoid that, we should have some schema drift self healing prompt. If any error is coming, if any table or column mismatch is happening, it will refresh your knowledge base by reconnecting the database again. Then I'm adding yes, continue. Continue. That means what it is currently doing, it is creating some guard files or Python files. Also, it is keep on updating the knowledge base. Now it is telling not just generic read only guard. So it is keep on generating the knowledge base, because the knowledge base is the only the source of truth. I added a schema validator for step 7. It checks query is still read only and that schema qualified tables exist. Okay. Schema validator.py. Onboarding core application, onboarding core customers. This is the reference. So what it will do? If any change in the schema or table names or column names, it will refresh the knowledge base. Now let me tell, continue the step 8. Step 8. What is the step 8? Sorry, step 8 is completed, right? My bad. Let me stop here. Continue step 9. Step 9. Look, what about step 9? Sorry, there is a numbering mismatch, I think. Okay, this is the step 7, step 8. Okay, step 9. This is called your step 9. Let me see where this is called your step 9. Query execution error fixing prompt, right? Now error check.md is ready. Now I will run the select query against post using safe connection details. Okay. So what it does, look, it is creating a error check.md file. Okay. Use this file to store sanitize post query errors, fixes and reusable prevent rules. Suppose now it given you a SQL query and you run against your database and you got some error. That means this query is not correct, right? Then you will tell to the AI, hey, this query is giving this error. So what it will do, it will try to fix and it will give you another script. If that is the fix, next time if you are trying to generate the same type of query, it will read from the error file and it will see the fixes, so that query generation will be more faster. If the error is caused by schema drift, refresh and record and affected object, it will create a knowledge base. This is the error. This is again one more knowledge base to fix the error quickly. Now let me ask for continue step 10. Example, I will capture the complete flow. Okay, onboarding names but error real schema is onboarding. Okay, this is a example steps, right? So what about the, now look, I'm again going to my, this is your example usage. It is give some instruction about the schemas, some table, how to write the, how it is write the SQL queries and all. This is just a documentation for the user, nothing more. Now next step is continue step 11. Cache query.md. Suppose, look here, there is another use case I'm telling, right? Now suppose I asked one query. After 10 minutes, I'm asking the same query. Do you think if it is again recreate the same query, it will take time, right? That's why it will make a cache file. In that cache file, last 10 user queries, user prompt or user ask questions, and its query will be recorded. If it is matching there, instead of recreating the same query, it will return the query from there. That means again it is a faster mechanism, or you can say cache mechanism. If cache hit is there, then it will get the file, it will get that query from that cache file. If it is missing, then it will return the, it will generate the automatically one more new query. Now you can see here, this is called my optimized. Okay, this is called your cache query.md. Use this file to cache the latest 10 validated PostgreSQL read-only query generated. Cache only validated read-only select queries. Keep only the latest 10 queries, not more than that. Store newest entries first. Do not store password, tokens and all. This is for safe side. Okay guys, this is about the automatical SQL query generator. Now let me tell, by analyzing knowledge base, can you give me 10 complex user problems or user queries and generate the SQL queries? I'm asking, right? I don't know about this database. So what it will do, it will analyze the knowledge base. It will give you a problem statement. This is just for a verification point of view. If you are using for the your production system, you can verify with your application owner who designed that schema and all, and also you can cross verify. Then you can use for your product and all. I have the relation map. I'm going to check few table columns, blocks for the risk fulfillment, identify tables and the 10 queries in the real time problem. Let us see what it is giving. I have got enough schema context now. I will validate generated SQL patterns through the read-only guard before presenting them. So the set stays inside your safety boundary. It will not directly give you the SQL query. It will cross verify with the guard SQL file. Then only if it is safe, only if it is safe, that query will be returned to us. All 10 SQL query pattern passed read-only guard. I will put the full set into a markdown file so you have a clean reusable query pack. Then I will summarize the problem in the final message. Okay, let it be do. So let it be generate the SQL queries. Now let me go to the PPT. Look, the same whatever the steps I executed there, right? I have documented here. First one is connect to the database, select the schemas, analyze the schemas, create the knowledge base. It should be read only. That is the reason it is creating a guard validator.py file. Next one is it should return the optimized query. Schema prompt also required. Heal drift also required. Fix errors. If any error there, it will fix the solution also. It will be documented, recorded somewhere. Next time it will help for the writing the query faster. Then examples. This is the caching. Now look here, work connection details, then you are using a Python test script for the schema analysis, right? Then you have to specify the schema should be available. You have to tell these are my schemas, can you analyze. Step 3 is metadata summary. It is creating a JSON file, right? If you go here, it is making a somewhere in the JSON file, I don't know where it is. Okay, this is the JSON, this is the metadata summary. The next step is knowledge base, then safety builder. The step 10, what is this? Optimized SQL query. These are the finally what it is giving. The generated query is read only, schema qualified, joined by foreign key, unlimited. Why this is safe? Now this, suppose look, this query is generated by the AI and it is telling it is safe. Foreign key join, required columns, order by. Now let me go to whether it is created or not. Okay, now see, you can see application status description, high risk application with customer and decision details, monthly application status trend. It contains 10 user problems with safe. Now look, this is called my created the full query pack here. These are the queries. So the how many applications exist in each application status. High risk application with customer and decision details. This is the SQL queries written by auto generated, right? Next one is monthly application status trend. Suppose I am writing, can you write a query for monthly application status trend? So what it can do? It will automatically generate this query so that you can execute. Also it has the capability to execute. For the time being, I am not executing against my database because there is no data in my database. But you can execute it. Then identity case document completion summary. So the each identity case with customer name, application number, case status, approved documents and total documents. This is the SQL query. Just imagine if you are writing by your own, it will take a time, right? First of all, you should have knowledge, database information, everything. Then only you can write this query. And this is helps for the basically your support engineers, they can use it, your developers, they can use it, anyone can use it. Okay, this is about the practical implementation of dynamic SQL query generator. Thank you guys.